So I wanted to show you guys a few things. Just know that this is not an exhaustive demo. This is a very like kind of an overview. There's a lot of meats and details in here, and I'm a developer first, coder first, and basically what I want to do is show some things that, for the most part, if you know who I am, have you met me? There are things that I like to talk about. Testing is one of them. Testing is a very good thing. It gets the developer environment fomented. It creates good resiliency in the developer environment and your code. And it's all people, right? So what else is similar to that engages so many aspects of our daily developer lives and our peers' life. And one thing that has gained traction over the past maybe 10, 20, I don't know, 40 years in computing is deployments, right? So we have the idea behind the scheduler, we have the idea behind your source code and getting your source code to the resources and executing it against the resources. That's what a deployment is, for me at least. It's getting your source code built and deployed and executed on a resource. And yeah, those type of scenarios do invite lots of danger. Remember the old days, you're probably deploying Apache, or you're probably deploying into the lap stack. That's your deployment with your application. Nowadays, we're doing containers. We probably have a lap stack on here, but the resources like the databases are all isolated units, and they're discrete, so we can easily point them out to our resource manager. And that's one of the things that we are experiencing now is, how do you do this efficiently? How do you take code and resources and point them together and dynamically? How do you point them dynamically? What if one disappears and you have another? How do you do this? So deployments are that thing. They're that thing that allow us to ensure that our application continuity, not only the application is working, but the continuity of that application is there as well. So deployments have a lot to do with staying available, right? Staying available, having deployed your code, you need it to stay available forever. We want to do that in a Spring Boot application. Many developers probably have done this. If you're, like Jesse, you've probably deployed tons of stuff and not even worried about it, since maybe the application framework that you're using handles perhaps the deployment. I'm kind of getting into the weeds in this myself, since it's kind of a renaissance. We have Kubernetes now. That's kind of like the number one resource scheduler. And we have a lot of what I would see knowledge churn, where a lot of people are going between Terraform, Kubernetes, and some mix of like OpenStack or OpenShift, and figuring out how to get the best performance ratio out of their development environment. So whether you're at a bank or you're at a school, you're going to find what works for you the best. And I'm just here to show you, hey, Spring Boot comes out the gate ready to deploy. And that's a good thing, because those are usually harder bits for developers. But me as a developer, I took it on. I took the line and said, let's deploy. Let's get our stuff deployed onto a server. Now, this is a quick bio of me. If you have any ideas or any questions, you can find me on Twitter at Mario Gray, or you can go ahead and view the source code for the demos that I'll show you today. They are on GitHub, Mario5Gray/demos. Now, I have a few links that I want to show to you guys up front. The links that I want to show you happen to be my links. That's the links to the demo, of course. But most of all, there's a couple of extremely well-written documents, like very concise documents out there that I would say deserve explanation. One of them is the build packs concepts. If build packs confuses you, like it did me, you will like it. You'll like the example in there that basically guides you about the process of a build pack. If I could probably show you that. These are some of the things that, oh, hi. Yeah, these are some of the things that I'm going to go through a little bit, is about how build pack works. I'm not going to build a build pack or go through it in gross detail, but I can show you the buildpack.io. Buildpack.io is essentially the Cloud Native Foundation CNF, Cloud Native build packs. They create layers, a way for us to build your code in a container and then create the actual deployable unit from that pack. So that build pack starts with maybe just an operating system, and then the operating system gets layered with a JVM, and then that JVM gets layered with a build tool, for instance. So you have like 3 layers. You have an OS, you have a JVM, and then you have a build tool. So those are multiple, multiple stacks within your build pack. But not to go into any gross detail, a build pack will allow us to quickly and efficiently build a container. That is, I want to build a container and I don't want to have to do this. I don't want to have to go to, for instance, I don't want to have to go to a Docker file, right? So normally you probably use a Docker file. So build pack will help us not to use the Docker file. And this particular Docker file that I wrote was going to take a JDK 11. So this is 1109. And it was a slim build. So the OS is a small subset of Ubuntu. And it's the current version of Ubuntu. I think it's Buster currently. And call it my build container. And then in my build container, I created a workspace. And if you notice that I had a copy command, I have 4 copy commands. What these basically do is take the data out of my current directory and move them into that build container, and then run Maven on it. So what ends up happening is I have a container that actually builds the thing, and then I have another container that says, hey, I'm going to take that container that you just built from, and then I'm going to push that jar file into it and say, given this container knows how to execute a jar file, I can say, once you've copied this file, create the entry point. So the Docker entry point just tells us once this container starts up, what should I execute? And that's what it's going to do. It'll execute my application.jar. So given that, what we wanted to do is we wanted to make it a little bit simpler for us to go ahead with these development scenarios and not have to engage the underlying container resource manager up front. And I think that the build pack Packito is doing that's a wonderful thing. Its nature is to bring us up a few levels from having to execute standard commands for resources that might change over time. And this is one of those things that helps us to maintain a semblance of, I would say, reality. That is, we're not going to be stuck in the weeds doing one thing, right? Like Docker files. We can continue with our normal development jobs, and that's very important for me. All right, so so the build packs aside, and that was a big just blab on that one. There's Spring Boot Docker, and as you know, you probably want to read this. Great documentation. I believe this was Greg Turnquist's documentation. And it goes quite a bit. It goes quite a bit about developing Spring Boot applications and then basically containerizing them. So if you want to know anything about containerization, and then you want to go to the next level, which is using the CNF the build packs, you can quickly do that within about 15 minutes here. I would highly recommend this article. The links will be at the end of this discussion, and it would be very good for the normal developer, the everyday developer, to essentially run through that scenario. So build your Docker containers. Don't build your Docker containers. Use a cloud native build pack to build your container instead, and you'll find the power there is very reassuring. Now, on to the next stage. We have a schedule for this particular talk. So the schedule is, of course, build packs. So I'm going to be talking about build packs for a few minutes more. So let's go there. But let's say that Docker image run. So here we go. Let's say that Docker image had a Docker file. How did I run the Docker file? here we are. So I'm looking for the command. And this particular command, I guess what you know about Docker, I would have built it. Let's see how long it takes. Actually, I should run that with time. Let's just kill that. Let's go back here and do time Docker build. Now, this probably takes a much longer amount of time than you want. So let's just skip that because this is a live demonstration. But we do have two scripts here. The first script that I have here is called build it. And actually, this is using the Maven tool. But first, I want to show you Packet. So what Packet does is it will run the Packeto's build tool for me, and it'll do all of the work that the Maven build tool does. Only thing is that I didn't have to engage with Maven. So something like pack build, the image name, and then the builder, the thing that I want to build my package with, my container with, which is in this case the Cloud Foundry CNB/Bionic. That's our Ubuntu image with JVM in it, and then tell it where the path is for the actual source file. Packeto will actually recognize what type of project I'm using. It'll say, hey, this is a Java project, so I'm going to go ahead and use JVM tooling for this. It'll pull down the correct resources. It'll build my tool, and then it'll actually emit a let's see if I gotta emit image name, export image name equals localhost 1000. Actually that's just a resource name, so because I've already prefaced it with buoy pack. So if I just packet to packet.sh, what's going to happen is my Docker container is going to receive the output of that build and run. Well, it won't run, but it'll finish compiling it. Now, this takes a second. So let's go to an IDE. And let's just skip ahead a little bit because with that running in the background, we can look at what Maven wants to do as well. If you notice, I told you I parameterized the build and said, hey, I need to know how what the container is going to be named. After all, I have to deploy it using a YAML file. We'll get to that a little bit later. But for the Cloud Native build tool and Maven, what we simply want to do is just use Spring Boot Maven plugin. So if you notice, I have my plugin, Spring Boot Maven plugin, and right now, I have a very simple configuration. You probably have no less, no more. You probably even have less. You really don't need this at all, actually. But for development purposes, we're going to do this. Show a little bit more like, well, how do we change the name of the container? So this is me pulling the image name out from the there you go. Yeah, so this is me pulling the image name out from the environment. I don't know why I did that completely, but oh, and saying that the image name is going to be prefaced with a project name. So I'm going to have an image name / project name. So this is a simple parameter. We should be no, we're not done there, but don't worry about that. If I ran Maven clean install on here, nothing happens because I haven't kicked off the build tool. But say I wanted to say that packet had finished by now, I would say something like Maven Spring Boot build image, and that will actually execute this piece of code here. Now, first thing I want to do is say image name equals buoy. Actually, it's not supposed to be image name. It's supposed to be resource path. So that should be resource path, not image name. My image name is really the project name, but this is really resource path. But I'll change that later because all of my scripts say image name right now, and this is what happens when you develop software and you go too long without refactoring. You end up figuring out that the names didn't match after all, and well, now you gotta now you have to kill everything. So this is still running, but that ran several times, literally a couple hours ago without fail. And honestly, I don't expect it to do anything different here, except for take a long time. And that's what we all know. We all have that wait phase. So if I did Spring Boot build image here, the same thing will generally happen. The image will build, and you'll get an output like this. This output will eventually ship the container to my Docker, to my local Docker, and then I could run it. because that's how we roll in Dockerland, I guess. But on the other hand, what type of other changes would I want to make? Those are some of the things that I want to think about going forward is how do I tell my container from Maven what the entry point is, for instance. Perhaps I want it to execute with a separate a parameter. But that's not the case here, but that might be the case for you. So being able to change how your application starts up is one of the things that we want to be able to exercise later on. And for now, we're fine with the current execution plan. So here we are. We have this guy. We have our, so that's where he is now, and I think I would have put this on 8080 and run it here. So what will happen is I will run this in Docker alone. I won't put it to the cloud yet. I'll just show you that, hey, this CNB based container executes. It executes pretty fast. It should run much faster, but I just remembered I am sharing my video, which probably means my computer is doing like a whole lot more work. This is usually why 2 computers are good, but that's fine. I have I'm not using Minikube locally here, which means that things will be a little bit faster in the future. So if I said this is a command prompt, right? Yes. So if I said HTTP 8080, remember this is on my local Docker running Docker native Docker for the Mac. So if I said actuator/health, there we are. So we have an actuator endpoint that has been running. Great. So let's leave that there. We know that this thing is running on my local host on port 8080. I can hit it. Everybody's happy there. The actual application itself has some sort of a trigger. Let's just explore that application really quickly so you guys know what's happening in the application, because I'll take it up a notch. I'll say, hey, we're done building all of the build packs. We're done building Docker images. We've done that already. I've shown you what type of power that we could get out of Spring Cloud, or I'm sorry, out of native build packs. So while that's happening, while I do that, how about I build this and then I show you this application really quickly. I understand my keyboard might be a little loud, so I'm going to try not to type so much, but I will explain because I think my voice sounds better than the keyboard right now. So I'm going to go into it. What we have to do here is we just want a standard Spring Boot application. That standard Spring Boot application should just bring us a web server. In this case, it's going to be a reactive Flux web server. It doesn't do anything except for listen on it listens for a request on /count. And once /count is hit, once somebody hits /count, all that it does is returns a response. It says, hey, latch countdown. I have a countdown latch up here if you noticed. This countdown latch is set to 2 at first upon application startup. So it says, hey, I'm going to count down the latch. The server goes, okay, I'm going to return the current count of that latch post countdown. Okay, so nothing else happens. It just counts down a latch once and then that's it. Now, what I did do also was I created a bean, and this is where it gets kind of like, well, what are you doing there, type of deal. So, oh, hey, here we go. So it read, so my image is at localhost 5000/Bowie latest. Great. So now I can deploy that using a deployment.yaml. But let's get back into that Spring Boot real quickly. Okay, now that the containers run, let's just see what the runtime behavior is going to be of this application. All right, so what is this guy here? He's an application event publisher. This is Spring Boot land. An application event publisher allows me to say, publish any event to the application context, and then somebody else can listen for that. And that listening receiver can then produce some sort of an action, like maybe shut down the application context, maybe restart JMX, or maybe start or stop JMX or something like that. You pick what you want your application event publisher to do. In this case, this application event publisher will only get executed once this countdown from that latch, that's 2, is once it's up, once it's done, once it's down to 0, latch data await will just disappear and it will actually run this event publisher. So essentially, this guy here, this bean, it's just a command line runner that sits on a thread. and listens for latch to go to 0. Once it goes to 0, you get a published event, and that event just says we have depletion. We're going to set the liveness state to broken. So what we want to do is at the end of our countdown, we want the application to be broken. That is, the app won't respond anymore. And therefore, whatever resource scheduler you have should see that, and it should say, okay, I'm going to take you out of the resource pool as a application. So that's what we want here. We want this guy to go out of the resource pool, pretend it's broken, so that it can get restarted as a brand new application. So the runtime state will get stopped, and then scheduled resource will get refreshed with the new instance of this application. And that's it. That's it for the behavior. Now, let's go over a couple more things. What is in my presentation here? I talked about Azure. I'm going to talk about Kubernetes on Azure, but I'm still talking about my Spring Boot application. Let's go to the health indicator. Since we're looking at source code, let's get the health indicator. What we have here is a bean, and this is a reactive health indicator. What it does is it allows us to say, we're basically publishing this information to actuator. So whenever I have something with the name health indicator in the method and the word my, for instance, it becomes the my health indicator that I can now address as a Spring Boot component. Okay, so this is a health indicator that will just push either 1 or up or down, and it basically asks the countdown latch. It says, hey, countdown latch, are you 1 or more than 1, I guess, or if you're just 1, you should go down. You should say, hey, there's no more. This health indicator is now going to tell the Spring Boot application that it is no longer available. That is the my health indicator. So just the my health indicator will say, hey, I'm down once the countdown latch reaches 1. That's one thing. The other thing is, and remember, this is just an indicator. This is not going to actually be any action. This is just indicating. So when Kubernetes asks, it's going to see, hey, it's down or whatever. But that doesn't happen until it actually goes for a request. In any case, we want up. Otherwise, it's 1 and it's down. But the bigger news here is not that I have a custom health indicator. Excuse me. The custom health indicator is not the biggest news. The biggest news is that I can configure these things from my application.properties. And in doing that, I want to ensure that I have, endpoints. So I want a health endpoint, I want the shutdown endpoint, and an info endpoint. So basically, these are, let's see, is this guy running? So if I did actuator health, you probably see, there we are. So currently a service is unavailable because I hit count, and once count goes down to 1, then the status is down. So that's my custom. That's reporting down right now, but the liveness and readiness are fine. So that's not going to take us out of the pool yet because liveness and readiness are fine. I could change that so that it does take it out of the pool. I don't do that yet. I just say, hey, just don't worry about it. Service is still online. It's just I have a component that's currently not working and I need to reconnect or something like that. So it might take it out of the load balancer instead. Continue processing your normal requests. Now, having the ability to expose these things and Spring Boot Actuator, which gives us this readiness probes, or not probes, but liveless readiness states. What we want to do is say, hey, management endpoint health probes enable. So that'll ensure that we get these states, we get these liveness and these readiness states. And then we want to include our own custom group, which you saw in code earlier, the thing that says, hey, is the latch 1, then it's down. If it's not 1, then it's fine. And then we have our actuator liveness states, which are what you see in here in these groups. So if you hit the particular group, like liveness, you'll get the status, you'll get whatever type of metadata that was programmed into it. So both liveness and readiness have a status, and they are currently up. But we could change that in about a second. We have a shutdown endpoint, so if you hit /shutdown, it'll take the application out. So we don't want to do that now. The server.shutdown graceful is the idea that if you do shut down the server, then only shut it down until all the requests that have been that are being serviced right now are done, but just don't request anything else. Don't service any more requests. So graceful just means make sure everything is like winding down rather than just cutting it fast. So that's why it's graceful. Okay. So let's see what happens if I did. Let's go back to HTTP 8080/count. Okay, now it's 0, and it should be down. Okay, good. So now liveness is down. So we turned, now it's not live anymore. Now our application is essentially dead. If you notice something, if you probably noticed that I sent liveness.broken, not readiness.broken. Readiness is just when the application is up, it's up. But now liveness is broken. So if you notice something strange, the application hasn't gone down yet, and that's because I'm running it on Docker. And that's on purpose, because in a second, I will just go ahead and deploy this guy on, oh, there you are. Okay. You're gone. Oh, heal. Oh, I almost got happy. Yeah, okay, so the application's still working. Now, let's go ahead and not run this on Docker locally. That was just a quick, one-off to show, yeah, it runs in a container locally very quickly. But what if I want to deploy this to, say, this is a deployment. What if I wanted to deploy it to, say, like a Kubernetes, service on Azure? This is what I'm doing here for this particular instance. Is I'll take that simple, tiny Spring Boot application called Buoy, that all it does is it has a countdown latch and some liveness probes, and I want to push it to a cloud. I don't want to push it locally, because if I do that locally, it'll literally kill my machine from all 8 gigs of its things. So I'll push this to Azure instead. Let's see. Let's make sure you're connected. Kubernetes context. It has my Azure cluster here. All right. The next I want to do is, now you know that my container is available. How do you deploy to Kubernetes? There are tools that I am learning that I will be talking about soon, which are going to make this part a lot easier. But here's a deployment YAML file. Let's not look at this YAML file too long. Don't look, or your eyes might burn. I don't want that to happen. I want everybody to be happy. Please don't look at this too long. Essentially, I'm going to use my repository version. So this is going to go to Docker Hub. This can go to my local host, but I don't have a local repository in Azure. So let's just go to my Docker Hub and use the thing called Buoy latest and deploy it. Now, one of the things that Spring Boot is really good at knowing is this section here. So remember, I configured liveness probes, right? Liveness state, readiness state. You need something to react to it, right? And so liveness probe here will react to it. This is my deployment YAML, or I have a configuration in the API. It says liveness probe, so I'm using liveness probe. And how do I get liveness probe? It's simple as statically binding all of the paths here, even the port here, and telling it its behavior. Hey, you should wait 20 seconds. If you hit it twice and it doesn't work, then you're failed. And wait 5 seconds in between, polls. Same thing with the readiness poll. Give it a URL, port, and some assignment. What do you call it? Some behavior, and then Kubernetes knows, hey, the Spring Boot app can either be up or down, and it could react to it. That's kind of the important part, is it being able to react to readiness probes. Finally, you have the service here. You have to be able to expose the service to the public. So in order to do that, we just create a standard service that points to load 8080, and it's a load balancer service. Excuse me. All right. So let's do the following. Let's see and make sure that this guy here is there. So let's k deployment demo. Okay, so we're going to redeploy it. I didn't want to start with already running deployment, so I'll just delete it and make sure that it's not there anymore. Good. All right, so really? Oh, that was weird. Okay, so we're going to go ahead and just deploy this. We launched this YAML file. I've said deploy a whole lot, and that's because this is Bootiful deployments. So if you're wondering why is he talking about deployment so much, that's because we're in Bootiful deployments. And Bootiful deployments means this is version 0.2. We're going to get to the point where we're literally deploying without breathing much. And as you know right now, I'm breathing quite a lot lately. It just happens to be a thing that I do. We have the simple application. Okay, I guess it's already deployed. So let's make sure, is it done? Oh, it is done. Okay. That was quick. Oh, it was quicker than I expected. Usually, I don't know. It shouldn't take that long anyway, should it? All right. We're going to see actuator health. Okay, so, all right, so yeah, it's running. And we can do the same thing. What we're going to do is just go ahead and say count. So that'll take the countdown latch 1. And it should be down now. And we should have a 503. Excuse me. Oh my gosh, that was indigestion. 503, service unavailable. This guy, hey, no, he knows we're not working right now. And why is it still live? That's because we never sent a message saying, hey, you're not live anymore. Let's just go ahead and hit that count again so that we could take, remember, the only thing that went down on the first countdown was my custom. So I could do whatever I want with that custom. I do nothing except for just show the custom. But what Kubernetes will do when that countdown goes to 0, right, this guy here gets executed, and it will then, this change will happen that will cause it to get redeployed. So this is one of the more important aspects. If you're a developer looking at it, going in maybe fresh, saying, how the heck am I supposed to use all of this stuff? You'll now see that you can control when your application gets redeployed, and that's what's going to happen here. Let's make sure that we have the behavior that we want. So if you notice, we have restarts of 1, and that's because the application restarted. And now we're back to a count of 1 again, or really it was 2, now it's 1 again. But we can do the same thing here. Okay, so now you know that's how that works. Great, awesome stuff. What's next, Mario? You showed us liveness and readiness probes, but what about secrets and config maps? Well, that's a good question, because secrets and config maps are the next section here.
Hey, Mario.
Hi.
Hey, I like to break into your talk, because I've been watching you demo, and then you jump into the next part and then the next part, which is amazing. But we are already running out of time, so I just wanted to check.
Oh, that's okay.
What else do you have?
Oh,
up
just
your sleeve?
Oh, that's it. It's literally, I went through the first 3 already. I'm at config maps. So our schedule is build packs. I wanted to talk about that. Kubernetes on Azure. I'm using Kubernetes on Azure to schedule resources rather than Minikube. It's pretty fast. You can deploy straight to it without much getting in between. App health probes. You have some readiness probes and liveness probes that keep our application running or keep our application in a constant state of availability. Then you have config maps. Config maps help us store configuration items inside of a YAML file that we can then deploy that will allow us our application to access those maps. So they're fun. Yes.
No, I think so. There is a lot here, and I think that's great. And I would love to invite you.
Oh, is that too much?
Yeah, because we have 25 minutes.
Oh, that's perfect.
Slot.
Yeah, I could do the rest in 25 minutes.
Oh no!
Or if it's too much, I can go over through the current. What's the stuff that I can explain more or better?
So what? Let's do this. Why don't we? We have a question here that came from Twitter. I think we can get the pop-up here on screen. Does build packs work with latest Spring Boot Kubernetes integration in Spring Boot 2.4.0?
I think it does. What specific integration are we looking for? But yes, what type of integration are you looking for? Spring Cloud, Kubernetes integration?
Yeah,
Yeah,
I don't know. That was the question. I think if it was more like a yes or no question. Like, does it support?
that will be a yes.
Yes.
They're heavily supported. Build packs actually came from a long pedigree of Heroku and Pivotal Cloud Foundry. It goes a long way to say that it's heavily supported, very much so.
So that's there's a lot to. It's funny. There's a lot to unpack about build packs. I think that's a
That's
phrase
the thing
that we
about
can.
build packs. Yeah, I know. It's I could show you. Well, that's why I wanted to show you the Docker file, and then I wanted to show you, hey, here's a Docker file, but here's a build pack road. Both roads
Right.
are viable. Some people prefer Docker files. I've talked to a few people, and they're like, Docker files, man, don't even bother with the other stuff. And I'm like, but you're missing out because what you miss out on with build packs is the ability to reuse resources, right? And
Right.
you might have a giant enterprise, and you have probably several different reusable components. Maybe you have a large project that has several deployables, but those deployables only share maybe 50% of the componentry. So what we do is package up the 50% and create little slices or stacks out of those. And from that point, you can then take the remaining and then build your most efficient build packs for your application by reusing those components.
So the interesting thing is on at least on Azure Spring Cloud, which is quite a new service
Yes.
in the cloud space. Today, developers only bring a jar file, and we use bad packs. Azure uses build packs to pack that jar file into a template that already exists in the backend. But in the future, it's on the roadmap that developers will be able to bring their own build pack so they can customize everything, right? What is your recommendation for, how far should I go in customizing my build pack, or try to leverage platforms if they can just take my application and run?
Well, if you're gonna bring your old build pack, I think it actually goes a far way to know if your build pack will be supported on that platform, or if the particular nature, maybe the architecture supported. Might be doing ARM, you might be doing x86. I know Azure supports both. So if your technology supports build packs on that platform, then go ahead and actually push your build pack there. But also, my theory is build packs are best when everybody's using the same thing. So if you are using only Azure, for instance, then use their build packs, right? Shoot for that. Shoot for what's easiest for your development, scenario. But if you're multi-cloud, you probably want to BYOBP, build your own
Okay.
build packs, I think.
That's a new one.
That's a new record. Yeah, and don't worry. Look, so build your own build packs if you have the need for it. Otherwise, if the resource manager does it for you, if there is a tool there for you, then that's awesome actually, because it'll probably be more optimized than say your own build pack, or your own build pack might be just as optimized but not as easy to use. So find the trade-offs there. I haven't used the one for Azure, the Azure build packs yet, but if it's cloud native supported, then it should be pretty darn standard and easy.
Excellent. Do you mind posting on your Twitter account so people check Mario's Twitter account, Mario Gray on Twitter? Would you mind posting there a link to the slides that you presented, so or you don't have slides or something? We don't have slides.
There's like
Can you
one
post
slide
it?
in here. There's literally this and that. There's two slides. The best slide is this slide here, because it actually keeps me on track for knowing what to talk about next.
Do you have a slide with links for other resources so people can learn more? Yes, this one.
There's the resources, yeah.
So here's can I ask you to maybe take a picture of this and post in your Twitter so people can go to Mario Gray and then just follow from there? I think that would be great.
Yeah.
While you do that, let me welcome my friend and co-host behind the scenes of this conference, Kirk Pepperdine.
Howdy,
Hello,
guys.
Kirk.
Hi, Mario.
Welcome.
Wow, that was an action-packed presentation. I really loved
Where
it.
did we go? Yes. Where are the rails? How did the rails look to you?
Oh, yeah, it was. Excuse me. It was good. It was like all kinds of good stuff in there, and I would say that one of the things I told Vincat, because he's like the probably the original live coder. I said, dude, you got to have a takeaway that people can come back and look at afterwards. This is no slides. This is screen capture it. And now if you go to Agile Developer, his library is there, right? With a screen capture of his presentation so that you can point people to say, because you're just like zipping through stuff. And I'm going like, hey, I want to go back and look. It's gone. Because you're just singing along really nicely.
You use this thing called horizontal scroll line on the video, and then you go all the way back to 15 minutes and 27 seconds to the exact point where Vincat had his slide ready to go.
That one, but he actually, I think his slide has like a Kotlin on it, or maybe it has like an IDE on it. If I could find a slideshow that allows me to have an IDE in it, that'll be great too. Actually, I think that's probably the best of both worlds, is a slideshow, a little IDE window, a little REPL or something like that.
So yeah, Venkat uses TextMate, and he does all macros. So when he do / or -- or whatever, something happens in the text.
Yep.
So it's quite interesting, and then he can just switch quickly to an actual Java code editor on TextMate with syntax highlight, and he never makes mistakes. Oh, his code always compiles and runs. I mean, like, what's going on with that guy? I don't get it. No bugs.
Zero. Why?
So frustrating. No compilation errors on Venkat's code.
Much code, right? How many chances for bugs do you have when you don't write much code?
It's all up to how much bugs do you want to write that day.
I mean, I'd like to say that, but then I have these really small demos, and I get at least 4 compile errors every time I make one change. So.
Well, I
try to
get one giant piece of demo and then just go, okay, well, there's a lot to explain here, so let's make the mountain look smaller. Let's make it look approachable. I've done the whole mountain run where it's like, that's a big mountain, I'm not gonna run that mountain. Okay, I can run that mountain. It's much easier than it is going down than it was going up. Okay.
So when I look at Venkat coding, it almost feels like he has a lint somehow or something going on when he types that automatically fixes all his mistakes on the keyboard, and then they're like, no, that's couldn't exist. He's actually hit every key,
right? He screencasts his demos and then scripts it, right?
Yep.
No,
that sounds like a great idea. Don't screencast and scriptcast.
When you think it's a text editor, it's actually a player.
Yeah. No, Vincat is just amazing.
TextMate 221, which is the TextMate 2.2, like that version of TextMate that only was made for him.
Yeah, exactly. They did a TextMate Venkat edition, something like that.
What's the what's the schedule here then? How do
we are unfortunately we are done with for the day. We're gonna wrap up, and Kirk and I will recap what happened today. It was an amazing day today. And we're gonna walk through the schedule for tomorrow. So Mario, you are welcome to hang out with us if you want, but I just want to close so we can have a nice cut of the video, but you can stay online. So for the on-demand video. So Mario, thank you so much for your presentation.
Thank you very much. Well, I enjoyed giving it. I hope somebody learned anything off of it. I aim for capturing your mind, and hopefully you got something out of there that made you go, oh yeah, I should probably look at that, or maybe that's a good idea,
Yeah,
awesome, great.
Developing, I guess.
So that's
I have a question.
That's wonderful.
Any of the other
so let's stop here, and then we have the cut. So bye everyone for this session.
Bye.
And now let's move on. Oh, Mario, you can come back. We can have Mario back.
Oh, I'm here.
We can have Mario back.
So I just want to ask Mario one question before he started in this. did you manage to see any of the talks? I mean,
No, I've been busy with families. We're
right,
back now, right? So I've been
like
busy
everyone
with
else.
other things. I have like stuff going on. Yeah.
Sorry, didn't want to put you on the spot. I was just going to ask you if you had a highlight yet, but to start. Okay, Bruno, why don't you take it away?
So today we had quite a day. Today was like almost like 99% technical talks. Yesterday we had at least 2 talks that were non-technical, and they were great as well. Today was a lot of technical stuff. We had a keynote that Marty and George from Microsoft shared what Microsoft is doing with Java, how it started, how it's improving, and how it's contributing back. I think to me, one of the highlights was how Microsoft changed in the past few years, and it was Microsoft made it possible for itself to be part of the Java ecosystem, or at least to get started, to get into the Java ecosystem and welcome a Java engineering group and welcome Java developers to work at Microsoft to help Microsoft be part of the Java ecosystem. That to me was the key to take away. But I'd like to ask you, Kirk, your perspective from the keynote. What are the things that you feel like were the major takeaways from it?
To me, the major takeaway from this was that Microsoft wants to engage with the Java community, and they want to be seen as doing the right things in the Java community, and they've been stepping carefully into this space and doing it in a way that I think has been very commendable. Just and you can see the progression. It's like we've come in, we've looked around, and now we're starting to contribute. And to me, this is just a perfect scenario, I think, is to have all of the big players.
Awesome. And Mario, any thoughts about this whole idea of Microsoft getting to the Java ecosystem, running a Java conference, and contributing to it?
So obviously, yeah, because Microsoft is big on workloads. Microsoft wants to own the computing resources for all of our workloads today, and that's something that we want. But on the other hand, it's a lot of trust that we have to gain with Microsoft, and that won't happen overnight. Even if they started as a big, fresh, multi-billion-dollar, C-suite startup, the guys that gave Uber a ton of money, and let's just say that they weren't at Microsoft, and let's say that Azure was a completely different company for a while, and they did the same moves Microsoft took. I don't think the community would be as open because then again, Microsoft has C#, and we love C#. We love the .NET platform, but we also know Microsoft, and they have a huge history of wrapping up ecosystems. But the way they came out with the open source a few years ago, VS Code, a few years ago, they made good introductions of themselves to the open source community first. By giving back to it. And I thought that was a really good idea because now it allowed us to really think of Microsoft as more of a steward rather than a competitor with the other vendors. So I think it shaped our minds, basically. They did a really good job at that.
Excellent.
Thank you.
We have 5 minutes to wrap up. So I just want to go over here. Today we had great sessions. Venkat came in and he rocked as usual, and then Trisha did an amazing follow-up with the content that Venkat showed. She just did it amazingly well, showing how to leverage modern Java on IntelliJ. We had talks about microprofile from Emily, Eclipse Audition, and IBM. We had sessions from Monica and Kate on ARM64 port and Apache Kafka. Melissa McKay came and talked about DevOps. Jesse G from LinkedIn, how they're moving to Java 11 in the whole infrastructure. And then Mario did amazing here with all these live demos as usual with Spring Boot and Boot Packs. This was super fun to watch. Today, it was a very technical day. And tomorrow, we're going to have last technical keynote but very important for all developers, not just Java developers, but all developers. If you are a developer and you want to learn more about the Java community, Mala Gupta will show you how the community works, how to be part of it, how to collaborate and talk to people, and how to behave and so on. Really be part of it. And Bruno Souza will come and share his thoughts on developer career, how to develop your developer career. I think that's a very important topic for many developers who are starting fresh, or even developers who want to switch from an area into programming, or from one sort of area into another area, still within technology. So Bruno has lots of experience on that. And
I would say that Bruno and Mala are both some of the most giving people in the community that I know.
Yeah,
why they're here.
They are.
I know Bruno is. I can tell you that. Like, boy, he's a giving guy.
He is something. He can engage you for an hour. He keeps going on and on and on. So tomorrow I'm gonna have a challenge to tell, hey Bruno, your time's up. You gotta stop talking.
I spent about a week with Bruno in Germany at some point, and boy, that was. Gosh, I when you want to meet somebody, talk development with them for a solid week and travel around. That's awesome, Bruno was a really good instrument in doing that, and I'm kind of scared of Bruno at the same time now, but at the same time I have a lot of respect for Bruno. I like Bruno a lot.
Yeah. So tomorrow we have a few interesting sessions. I would actually like to get Kirk. What is the one session nobody should miss from this guy?
Oh God, at the risk of offending every single speaker on that list, I mean, they're all awesome. I'm going to pick on Heinz, mostly because I can pick on him because everyone's going to say, of course he picked Heinz. He's my co-founder of JCrete, yada, yada. But, Heinz has done something really interesting with Loom. I hope he gets a chance to show it, because up until recently, I had done a 1,000,000 socket benchmark. And, I don't think anyone else had done that before, or at least not published that we could find. And Heinz with Loom has shattered that, I'm happy to say. And I hope he talks about it. So
is it 1,000,000 socket of pings or 1,000,000 sockets of streams?
We had 1,000,000 clients attached to a single server.
Yeah.
And we were sending data to the clients from the server, WebSockets.
That's WebSockets.
Yeah.
Oh yeah. Anyways.
To a server. So Loom, man. Yeah, that's some awesome stuff. I love that stuff.
What is your one go-to talk from tomorrow, Mario?
For tomorrow, I believe it's going to be Loom too, but like I probably will say that the I don't know. I think the Loom thing sounds the best. Keeping Java applications secure might be cool, but that could break down a whole lot. But Loom is like one of those nice nuggets that you want to pick up and kind of read and know about, because it's going to provide some awesomeness.
Yep.
Scalability. Do you like scalability? Sure you do.
Everybody wants. Not everyone needs, but everybody wants.
Well, everybody wants growl too, but like nobody needs it.
All right. So in fact, yes, all of these sessions are really good. We picked them carefully. We invited these folks and they accepted, and they said, hey, can I talk about this? Can I talk about that? And we were all good with their interest as well. Simon Reeder works for Azul Systems, who is a partner of Microsoft on Azure. We use Azul Zulu JDK on Azure. Dr. Hai is a great friend of ours, great friend of Kirk, and he was very kind to share his time with this initiative. Reza Rahman will share his experience on Java EE. For all the Java EE folks out there, Reza. He's a passionate person for Java EE, and he will share how he is working with the Azure engineering team to bring Java EE support on Azure. Rich Turner from Windows and .NET group. So Rich is a .NET person, but he works on Windows a lot, and he was very kind to learn Java and get updated to Java and show how do I do Java stuff on Windows. So he's going to show about the Windows Terminal, Windows Subsystem for Linux, and a few other tricks. We have Jonathan Giles from Azure SDK team. He will not talk about Azure SDK. He's actually going to talk about how to design great APIs, great Java APIs. All the Azure SDKs for Java were rewritten from scratch following his guidance. And Jonathan Giles worked on the Java team at Oracle. He worked on JavaFX, and he's been designing Java APIs for many years. Atsun Yanaga from Red Hat, another partner of ours, will show Quarkus and play with VS Code and deploy that to Azure OpenShift. Finally, Deshaun Carter, who recently moved to Redis Labs. We'll talk about Azure Spring Cloud. And we're going to wrap up the day and the conference with an Ask Me Anything with the Java engineering group. We're going to have myself, Martin, George. We're going to have Kirk. We're going to have Monica and a few other engineers from the team that join us for 30 minutes to answer any questions. And we're just going to have a nice chat. So with that, thank you so much, everyone, for staying with us for day 2. Thank you so much, Mario, for your time. And thank you, Kirk.
Thank you, Bruno. This has been an awesome ride for you.
It's been fun. We'll see you all tomorrow. Take care.
Get some rest. Bye.
Hey, man. Later, man.